Hello everyone. This is Carmen Ng from SGS Hong Kong, Connectivity and Products. It's my honor to speak to you here on what is green electronics and how you can achieve it. So this is our agenda today. We'll first talk about the common criteria one by one, first on sustainable by design, and then on climate change, where we also call the carbon footprint, as well as the chemicals used. And then we'll talk about how you can prepare for now on data and transparency and on conformance, as well as wider sustainability, and how you can navigate in the future. These are the four main modules under the green electronics. First is the sustainable use of resource, including what we also call the circularity module. It is mostly designed in the design stage, including the selection of material, as well as the component parts. The second module comprises of the carbon footprint, or the greenhouse gas emission. It includes the product's impact on climate change in its life cycle, and other environmental impacts caused by the product can also be grouped into this module. The third criteria will be on chemicals and concern. It includes the chemicals that can negatively impact the human health or the environment. And then the fourth module would be on responsible supply chain, ensuring that the environmental and social sustainability is considered at the time of sourcing. There are different criteria that can be considered under each module, so we'll pick only some of the criteria here for the limited time. On the first requirement, the sustainable use of resource, material selection can be one of the major criteria here. In here, recycled content and bio-based plastic contents can minimize the impact of your material in products. For recycled content, it can be further classified into pre-consumer and post-consumer recycled contents. Both refers to the material that has been reprocessed from recovered material, and pre-consumer recycled contents refers to those diverted from waste stream during manufacturing process, but it excludes the reutilization of material in scrap or rework reclaimed within the same process. While the post-consumer recycled content refers to those generated by household or commercial end user of the products. In some regions, the use of recycled content can be restricted from some of the end use. For example, if recycled content is to be used as food contact materials in European regulation, there are additional requirements that can apply. For the certification process of recycled content, it primarily makes use of document check as well as on-site audits. For a limited number of materials, certain materials, for example, PET and PP, verification testing can be one of the ways to verify the recycled content in material. And for bio-based plastic, it means the plastic is originate from biological resource, such as starch or cellulose or corn, rather than fossil fuels, which is not regenerable from the environment naturally. Some consumers may confuse bio-based plastic with the other term, biodegradable, and we have to mention here that bio-based and biodegradable are two distinctively different terms. Bio-based refers to the origin of the material from biological source, and biodegradable refers that it can be broken down in the environment by living organism, referring to its end of life. So these terms are completely different. There are a few bio-based plastic which is already available commercially, and it includes some cellulose starch-based plastic, as well as commonly used aliphatic polyester, such as polylactic acid, the PLA. So these are the common bio-based plastic on the market. The bio-based content can be verified by testing. Because these materials are originating from living organisms which have been actively taking up the radioactive carbon-14 in the environment. So the carbon-14 test will be a precise and practical test for testing the bio-based content in a material. Another important metric under this module would include the product longevity and the design for repair and recycling. Durability or reliability for products is essential criteria under this module. The assessment could be conducted on the material, such as polymer, or could be conducted on finished products. The design for electronic and electrical equipment could be evaluated against the repairability assessment as well, according to the applicable product category rules. And we'll show one example in next page. For recyclability, products, material, or the packaging can be assessed against the recyclability criteria. For electrical and electronic products, it helps to comply with the recycling and recovery requirement in the WEEE regulation in the European market, saving your EPR costs when going into these markets. For packaging material, structural evaluation on body and accessory material can help to reduce packaging waste generated from your products. So one example here we show is the France Repairability Index assessment. It is the example taken from a washing machine, and it is evaluated against the France AJAC law product category rules. The assessment could deliver a result of single repairability score out of the 10, and we can also provide recommendation for improvement and also help to compile the instruction manual to end user. Apart from circularity, the climate change mitigation exercise within the product lifecycle is another major module for green electronics. We've picked a few major criteria here under this module. For the assessment of climate change mitigation in products, life cycle assessment is a crucial tool in evaluating this. The outcome would be the product carbon footprint, which evaluates the greenhouse gas emission within the product's life cycle. If the quantified results is intended to be communicated, the results should also be externally verified with a third party. With LCA, the life cycle assessment, other impact categories such as water scarcity, resource use, eutrophication, acidification can also be determined with this methodology. This highlights the major step of an LCA. The steps in an LCA includes the first step is to define the goal and scope of the assessment. It's usually cradle to grave for finished products, and it's usually cradle to gate for semi-products. It is then followed by the inventory analysis on the activity data within the defined scope. We can then convert the inventoried activity into environmental impact. And in this step, if only the climate change is considered in the impact assessment, then it is the common product carbon footprint that we talked about. Alternatively, if we are assessing the wider environmental impact, for example, ozone depletion as well as other environmental impact, then it is the full LCA that is conducted. For example, the European method of life cycle assessment consists of 16 environmental impacts to be assessed. Finally, the results is interpreted in a study report. And if this report or the LCA results is to be communicated externally, it has to be verified by a third party for the methodology and the results interpreted. For energy-related products, the energy efficiency is another crucial criteria to be evaluated. The assessment is based on the available product category rules, and usually energy labeling is according to specified format, according to the requirement to that product category. And the example here shown is the energy labeling format of the European requirement, again on washing machine. This is the third module under green electronics. The use of chemicals in the product life cycle is also essential here. And this page illustrates the substances that are restricted in electronics. There are a lot of different requirements that restricts the chemicals in electronic products. First, there are the product-specific requirements, including the well-known RoHS requirement in electronic products in different areas, including the EU as well as other markets. And we also have the battery regulation that has the heavy metal requirements for battery. There are also other chemical management restrictions for all products, such as the REACH Annex 17 regulation in the EU. And we also have the persistent organic pollutant chemicals, the POPs regulation, under the United Nations framework called the Stockholm Convention. In addition, some substance that could negatively impact the recycling of material is also restricted for some product categories. For example, the halogenated flame retardants in electronic displays, such as TVs, is restricted in the EU. And if these restricted substance is present in the product, it's not only that it is not green, it is also refrained from some major markets. Apart from the restriction, there are increasingly more requirements set against the chemicals that should be communicated along your supply chain. It includes the declarable substance list according to a new IEC standards, IEC 62474. And there are also some disclosure requirements in a list of new EU regulations, including the battery regulation and the upcoming, for example, proposed toy regulation. This is called the Substance of Concern Disclosure, the SOC. And this list of SOC can include those that is previously mentioned, for example, the persistent organic pollutants, as well as the substances that are negatively impacting the recycling. It also includes the substance of very high concern, the SRC, as well as some harmonized hazard classes of chemicals under the CLP regulation, which can negatively impact the human health or the environment. You can see that the communication along supply chain will become essential in the future. So here we will be showing how to effectively collect data along the supply chain. There are different aspects to be considered here to plan for the future. First is the data structure for your data of the products, serialized across data models, across the batch, and for each individual item, which is also called the level of granularity of data. Serialized data structure can allow effective management of vast amount of data to cater for upcoming new requirements such as the EU Digital Product Passport, the DPP. Second criteria would be on the supply chain transparency. And it consists of data, traceability, and trust along the supply chain. So data are dispersed across the supply chain from upstream to downstream, so the data here are quite loosely bound. And the traceability can connect your data from upstream to downstream. Finally, verification of these data can give trust to your data, and this is the whole picture of data transparency along the supply chain. You can also manage these via external platforms, such as some sourcing management platform. With supply chain transparency, you can also further set strategy in sourcing to effectively manage the new requirements in value chain so that their environmental and social sustainability is assured. In requesting for vast amount of data, there are usually 3 types of response from your supplier. First are some best supplier with their morale in hand so that data is already available in-house. The most common type is the transactional value that suppliers works with. For this common type of supplier, you may have to group your orders into one big order so that you can have better transactional value to gain meaningful data from these suppliers. The last type would be the refusal. So no matter how big is your order, they may not cooperate for this complex agenda under sustainability. But the sustainability goal under the UN will not just go away. So there will be more countries implementing these criteria. So if supplier is not working on sustainability, they may have to face market shrinkage in these aspects. So it may be useful also to understand the product sustainability principle in wider sense. For product manufacturer, you may have to know that we are now transforming from product compliance to something we call the product conformance. So compliance is something that you have a limit, you get a pass-fail, like you send the product to SGS and you get a pass-fail test reports. While product conformance is your adherence to higher product sustainability principles, instead of just slightly hopping over the passing value. So a recent resource published by the ISO, the IWA 48, provides some guidelines to wider ESG principles. So a quote here, ESG is not a fixed position with a pass-fail limit, but a journey of growth and deepening ESG maturity, integrating continual improvement. This is a free and useful guideline document for business. It includes some example of actions that you can take, and there are some suggested KPI on your sustainability journey. And there is a maturity matrix as an indicator of 4 levels here. We'll detail in the next page. And verification can also be a useful tool for your conformity assessment. You can scan the QR code here to arrive to that ISO standard, which is freely accessible. And this is the maturity matrix quoted in this guideline. On your journey, you will go through 4 steps of your maturity in the ESG journey. And starters usually takes ESG as a lip service. And the second step, you will become knowing what to do, but probably it's a box ticking in a mechanical way. And then the third step, you will know how to go on the ESG journey, going beyond the minimum requirement that is required by your customer or by the regulation. And in the last stage, company becomes knowing why ESG. They are principle-driven, and they can demonstrate leadership to the industry. At this stage, a company is completely ESG mature and could be the best to work with. And this maturity matrix is a useful self-assessment for your sustainability journey. And as a partner to your journey, SGS provides different services. Performance marks can evaluate your products against some set criteria, including durability, energy efficiency, as well as some others, for accredited performance recognition to your products. We also have the Green Mark scheme, which provides certification or verification to some common product sustainability aspects. So this includes the recycled content we've just mentioned, some chemicals, for example, PFAS-screened or hazardous substance accessed, or the bio-based and PVC-free. And we also have the product carbon footprint verified mark. These claims the certification process of SGS marks is simple and easy to follow. We can also make the claims traceable to the verification test conducted behind so that consumer can know what is done behind these claims to increase consumer trust and minimizing the risk of greenwashing. This is the sharing of one of our customers, Samsung. The certification process for its hazardous substance assess mark for their OLED laptop display panel was clear and easy for them. Apart from SGS marks, we can also assist with some external certification. The examples here includes the Eco label, the EPEAT label, hosted by the Global Electronic Council, the GEC. It classified the products into different ratings, the gold, silver, and bronze. And actually, the sustainability criteria we quote today are referencing from the criteria under this program. We also assist with some specific claims on recycled contents, and we can also provide assistance to some EPD, the Environmental Product Declaration, the most popular being the EPD International and the PEP Eco Passport. If you're interested in getting an external certification, here are the progress with the EPEAT program we've mentioned as an example. You will first have to register on this platform and then engage with an approved conformity assessment body, for example, SGS. The product and the process will be reviewed against the set criteria of the program. If it is EPEAT, then the criteria we've just mentioned, and then get the certification published. Ongoing verification may also be required for some program. So if you have any need, feel free to scan this QR code, get my contact, get connected, and check with us. Thank you.